Alright, so in the last video I talked about the own price elasticity of demand, and in this video we're going to talk about the cross price elasticity of demand. So I mentioned this just briefly in the prior video, but I didn't really go into it too much. And before I get into it in this video, I want to say that if you don't have a really good mental image or you don't have a really good grasp on substitutes and complements, that I would go back and review those videos before we get into this, because it will make a lot more sense and you won't get as lost if you remember these two. So if you don't remember these two, go back and review those, and if you do, then we'll just get on to what the cross price elasticity of demand is. So what this whole concept is getting at is if the price of another good in the market changes, how will that affect the quantity of the good that I am worried about? So this is written normally as the elasticity of x, y, where x is the good whose price is changing and y is the good whose quantity is changing. So that's how I've always seen it written, and there are different notations. Maybe these two are flip-flopped. You just have to look at your book and see how they decide to write it. So the way that the first definition that I like to give for this, which is the same one as the first definition that I gave for the own price elasticity of demand, is that in this case, this is the percentage change in Q, in quantity, of good y, divided by the percentage change in price, in P, of x. So what's going on here? What's really going on is that we're not talking about the change in the price of y. If I had written, let's just do this really quickly. So if I had made this the percentage change in the price of y, then that would be an own price elasticity of demand. So it would have been, how does the quantity of y change when I change the price of y? Now we're talking about if I change the price of not y, but of x, of a different good. So when the own price elasticity of demand was talking about changing the price of the good whose quantity you're worried about, this one's talking about the change in price of a different good in the market. So now I just want to write out some other ways to express this exact same idea. So you can write the percentage change in the quantity of y as the change in y over the old y divided by, and the percentage change in the price of x you can write as the change, and I'm just using delta, this triangle, for change in the price of x over the original price of x. And another way of writing this change here is you have the new quantity of y minus the old quantity of y over the old quantity of y, a little sloppy, sorry, divided by, and we can do the same thing here, the new price of x minus the old price of x over the old price of x. And then lastly, if I think it gets a little confusing to look at all of these, this fraction on top divided by this fraction on bottom. So another way that this is commonly written is if you flip this entire thing, and I'm just going to write it out in the shorthand with the deltas over here. So if you flip this thing, you can bring this bottom fraction to the top if you multiply by the reciprocal. So you can have the change in the quantity of y over the change in the price of x times the price of x over the quantity of y. So these are all alternate definitions for the exact same concept. And then just like I did in the last video, I do want to give you, just so you see it once, the calculus version of this exact same thing. So I'll just write this in green, and we'll put a little calculus by it. The calculus definition for this exact same concept is it's the partial of the quantity of y with respect to the price of x times the price of x over the quantity of y. And I'm not going to get into talking about the difference between these two, but really this is just, the calculus version is just a more precise measure than this kind of version that we're working with here. But I think this one's a little more intuitive and easier to work with, so we're going to just work with this one. So I put this question up here and just kind of skipped over it, and now I want to go back to it. So if the price of boogie boards decreases from $10 to $7, and I'm using boogie boards because that's what I used in the first set of videos when we were talking about substitutes and complements, will I sell more or less surfboards? And how many more or less will I sell? Then finally I said assume boogie boards and surfboards are substitutes, just to kind of refresh your memory. So substitutes are when one good can replace another good. So boogie boards are getting cheaper. They're going from $10 to $7. So I'm going to assume that, I know because boogie boards and surfboards are substitutes, that we will sell less surfboards, because substitutes compete with each other, and since boogie boards are now cheaper, more people are going to buy boogie boards and less people are going to buy surfboards. So what we're really answering here is how many more or less will I sell? So let's say, just to work through an example, let's go ahead and say that when boogie boards were $10, so when P, and I'm just going to write P sub B for price of boogie boards, was equal to 10, let's say that the quantity of surfboards, so Q sub S, was 5. I sold 5 surfboards. So now, let's say now the price of boogie boards is $7, and let's say the quantity of surfboards is 4. So I sold less surfboards, but only 1 less. So what will be the, let's go find the elasticity of boogie boards, the cross price elasticity, boogie boards, comma, surfboards, just to keep this notation similar. So the price of boogie boards is changing, and we're wondering about the quantity of surfboards. So we have the percentage change in the quantity of surfboards. So let's go figure that out. And we find that out again by new. So 4 minus 5 over 5. And then this entire thing, that's just this part right here. This entire thing divided by, and we have this over here, we have the new, which was 7 minus 10 over 10. So working through this, 4 minus 5 is 1 over 5, or sorry, negative 1 over 5. So we have negative 1 over 5 divided by 7 minus 10, that's negative 3 over 10. And rather than do that out, I'm just going to multiply by the reciprocal, which is negative 1/5 times 10 over 3. 10 over negative 3. And finally, we are going to get that this is equal to the 10 and the 5. We can cancel that and make this a 2. And so we are going to have negative 2 over negative 3, which will just be 2/3. So what this says is for every 1% decrease in the price of in the price of boogie boards, excuse me, there will be a 2/3 decrease in the quantity of surfboards. So I'm just going to write this out because it's a little confusing to just talk about it. So what this means is that a 1% decrease in the price of boogie boards and the P sub B leads to a 2/3% decrease in the quantity of surfboards. So I'll just write Q sub S. And vice versa, if we were to make this, I'll change up colors, if we were to make this an increase, then that would lead to a 2/3% increase in the price in the quantity sold of surfboards. So that's a lot just to cover in one video, but the last thing that I want to say, and this video wouldn't be complete if I didn't cover it here, is that substitutes have, and I'm just going to erase this little bit up here, that substitutes have a cross-price elasticity that is greater than 0. And complements have a cross-price elasticity that is less than 0. And that should kind of make sense intuitively, even though this is a lot to cover all at once, is that substitutes, if the price of a substitute drops, the quantity of the good you're selling should drop. And if the price goes up, then the quantity that you sell should go up because you're competing. And complements work the other way around. If the price of a complement goes down, then the quantity of what you sell will go up, and vice versa. Sorry, I just lost my train of thought. If the quantity for a complement, if the quantity goes up, sorry, if the price of a complement, that's where I was. If the price of a complement goes up, then we would expect demand to go down for the good that we're selling. Quantity demanded to go down. So that's all that I'm going to cover in this video. My brain's a little tired, as you can tell, and I'm sure that yours is as well. Let me know if you have any questions, and just work through a couple of these. That's really the biggest thing with all of these elasticities. It's just kind of getting an intuitive feel for the formula and then being able to work with it and know what it actually means.